number key to change.
Yep, window number
Desktop.
key or Alt Tab.
Emily, can you hit present to everyone too? I don't know if this is required, but
Okay.
yeah.
Okay, I'm screen sharing and presenting to everyone. And then 3, and then I'll up that. See if I can do that. Oh, nope. Okay. Well, everybody gets to see my host name. No big deal.
Sorry.
It's
you can
okay.
just set PS1 equals no, and then equals like right chevron or something.
Let's put a dollar sign. Like so?
No dollar sign,
Oh.
just quotes. Single quote, right chevron, single quote, or dollar sign or whatever. Yep.
There we go.
Now clear again. Thank you.
You've got Meta 2 takes you to DNS, Meta 3 takes you to terminal.
Perfect. Thank you for your help.
You're welcome.
So I do have did install. Okay, you do. Cool. How did your third presentation go?
Pretty intense.
Cool. You'll have to give it to me sometime. I'm sad I missed it.
It got recorded successfully.
Oh, cool. Right. Recording.
Recording works
That's a good
with
thing.
my talks. I put in my obligatory hours of sale.
Oh, thank you. Yeah, I was there too.
Oh, excellent.
Okay, we'll give everyone a couple more minutes to filter in.
Yes, absolutely.
How's everyone doing? Good?
Good.
Tired yet?
Yeah.
Yeah, I'm tired too. But I get to drive home after this. I live in Oregon. It's not that far.
In Corvallis.
Yes,
Wow.
Corvallis. It's about 4 to 5 hours, depending on traffic. Sometimes 6.
Have you given any other talks, or you've been listening to talks?
Just this one. This is my first talk. Lots of my students have been giving talks, though. Emily, Donna, Lucy Wyman, and Elijah Boyd is also giving a talk. He's giving a talk right now. Hello, people.
Hey.
Hello, Jordan.
You guys coming to heckle?
We
Absolutely.
are coming because
Which
which flavor of heckling would you like?
All of them.
All
At the same time.
Tweet that have done
Yes. I don't know how to. I don't have a Twitter. No, that's a lie. I do have a Twitter. I've only logged in once in like 2012.
You don't have to be on Twitter to be on Twitter.
I know. I'm just saying I won't check Twitter.
Honestly, Twitter will check you. I think that
Yeah.
everyone on Twitter is doing a service. Remember the immortal words of Oscar Wilde? The only thing worse than being tweeted about is not being tweeted about. Yeah.
Okay. Where do you pick this up?
But I want to heckle.
I've already got to be careful to heckle. So.
I want to help.
Oh,
He's a professional heckler.
I can't do it all myself. I'm gonna need help from the whole room.
Okay. Hi, everyone. I'm Jordan. I work at the Open Source Lab at Oregon State University. It's in Corvallis, about 2 hours south of Portland. I'm here to talk about DNS. Hopefully you're here to listen about DNS. If not, you might want to find a different room.
I thought this was OSL Anonymous.
Yeah. So how many people in here are OSLers? Yeah.
You de-anonymized us.
Huh? Yeah, I know. That was the trick. I just trolled Corbin. So, DNS. Before we get started, I just want to see a show of hands. How many people know something about DNS? A little bit? How many people know nothing at all about DNS? Okay, a couple. Cool. This talk's fairly introductory, but feel free to ask all kinds of questions because I will forget what people don't know and what people do know. I don't know. So DNS stands for Domain Name System. It started out primarily as a way to translate domains into IP addresses. It does a lot more than that nowadays. It's stored as a distributed tree structure. If you know what a tree is, it's really awesome. If you don't, You should learn about them. They're really cool. We'll talk about it a little bit more. So DNS is super, super useful. We don't have to remember IP addresses. Who likes remembering 4 numbers from 0 to 56? Yeah, no, okay. You guys are strange. Load balancing. Lots of people do load balancing with DNS. We can talk about that later. I won't really talk about it much in this talk. If you're interested in it, come talk to me afterwards. MS for email. Email's dependent on DNS. You can't do it without it. It decouples domains from their IP addresses. And it's also extensible. Lots of new record types are being added every year. There are a couple added last year, I believe. I don't know if any have been added this year, though. So we're going to start by going through some of the basic record types. I'm sorry if you're familiar with them all, but we'll get through them. So A records are the simplest record you can have. They have a domain, which in this case is osuosl.org. They have a TTL, it's an expiration time. We'll talk more about it in a bit. In A, just means it's an A record. And they point to an IP address, 140.211.15.183 in this example. So just a bit of terminology that I unfortunately forgot to make a slide for. I'm going to be calling the domain that we're asking questions about the query, which in this case would be osuosl.org. The answer is also osuosl.org. That won't always be true. The TTL, or the expiration time, is the number right after. And in A, it just tells you what kind of record is returned. Yes, Emily.
Why is there a period at the end? Like, if I type in...
We'll get to that.
What does A stand for?
A, address.
Oh, good answer.
Yeah. What's quad A stand for?
Address.
Yes, I don't know, actually. Huh? Yeah, so quad A records are exactly like A records, but they're for IPv6 addresses, not IPv4. I don't know why they're 4 A's or instead of 2 or 3. Someone like them. You can have more than more than one A record per domain. You can actually have any other record type you want with an A record, except for C names and D names. We'll talk about those in a bit. MX records, like I mentioned before, are for mail. They're a little bit more complex than an A record. So you have your domain, you have your expiration time, you have your query type. You also have this new column. It's priority. It's just more arbitrary data. In the case of mail, it tells you which email servers to try first. Our email servers all have the same priority, so we don't really care which ones you try first. Yes, Emily.
If there were different numbers, would the 5 be top or bottom priority?
5 would be the most important. So try lower numbers first, then try higher numbers.
Wait, wouldn't that be least? Oh, okay.
Depends on how you think about it. When you go to send email, your relay will look up the MX record for a domain and try and send email there based on the records that are returned. NS stands for name server. Name server records tell you where to find more information about records, which gets kind of weird later. We'll talk about that. So they're basically the same as A records, except they point to domains instead of IP addresses. They're NS records instead of A records. That's about it. They tell you where to direct more DNS queries for subdomains. Typically, the domains they point to should have A records. If they have CNAME records, someone's doing it wrong. Another important one we're going to talk about now is MX domain. That means there's no answer. Depending on which DNS queries you're asking, sometimes they won't ever return an NX domain. They'll do that because they want to redirect you to some other server if you're making a query, and then they can serve you ads. So dot, the root. Dot is the root of the DNS tree. I'm using this utility called dig. It's really cool. I'm looking for the NS records and dot, which is the root of the tree. If you know what a tree is, it's the root. Dot has 13 name servers. They are A through M, dot root-servers.net. Those records basically never change. They also have A records, which we'll see in a bit. They're known as the 13. It's a very creative name. There's a website you can visit, www.rootservers.org, right there. They'll tell you more information about them. The people who run them think they're really awesome because they've been running them forever and they underpin the entire internet structure. Both A and J are run by VeriSign. Yes, Corbin.
Why are there 13 and not some base 2 number like 16?
There's 13 because Paul Vixie said, hey, who wants to run NS servers for root? And a bunch of people said, hey, I want to. And there are 13 of them. I don't know if he was specifically looking for 13 to begin with, or 13 responded. A and J are both run by VeriSign. I don't know why they run 2, but they do. No one else runs 2. The other people who also run root domain servers and name servers, there's the University of Southern California, Cogent Communications, that's an ISP in the United States. University of Maryland runs one, NASA runs one, Internet Systems Consortium runs one, the Department of Defense runs one, the Army runs one, a company now called NetNod also used to be called Autonomica. First one outside the United States to run one, they're in Sweden. RIPE also runs one, ICANN runs one, also both in the US, and Wide runs one in Japan. However, although there's 13 name servers, there's a lot more actual servers serving up all of these queries. Does anyone know what Anycast is? It's a networking. Want to explain it?
No.
Okay, Corbin, you look like you want to explain it.
I don't know if it's already been explained yet because you asked everybody, but Anycast is when you just kind of yell something out and then wait for one or more people to say something.
Yeah.
And then perhaps you yell it again, just in case anybody didn't hear it the first time.
So Corbin's answer was in the form of the joke based on what Anycast does. In networking protocols, Anycast is you basically say, anyone can answer this who wants to pretend to be this IP address. And they can answer you. So the nice thing is you can have lots and lots of servers serving the same IP address. Whoever gets the query first is that IP address. For example, USC only runs one server for, I don't remember what they are. I think they're C or B. ICANN runs 155 servers on the same IP address using Anycast. It's really cool. This picture here, it's from Hedgehog, which is ICANN's monitoring and graphing tool. If you visit their root server, I think it's L, they have this website. It tells you information about it. I took a picture because I thought it was cool. Asia Pacific at the time was making the most queries. It was like 2 in the afternoon though. It's kind of interesting. Europe was also beating out the United States at that time. Everyone must have still been awake and making queries. One more concept to get through before we start doing more interesting things is authority. DNS authority is entirely arbitrary. Don't think of it as the ideal concept of authority. Anyone can have authority in DNS if they say they have authority. So you're authoritative if you want to be authoritative. The root servers are all authoritative for top-level domains and generic top-level domains. Does anyone not know what a top-level domain is? It's .com, .org, .net, those kinds of things. Generic TLDs are controversial. I don't really want to go into those. Name servers all have SOA records, which is start of authority. That's how a DNS server says I'm authoritative for this source. They all have, all the root servers contain SOA records, NS records, and A records for the NS servers. And the records that they point to, servers they point to, have A records and SOA records, and so on. If you want to serve records for a domain, you need an SOA record. So let's go through a recursive DNS query. Our goal is to find the A record for osusl.org. So we start by querying the root servers. We say we want to find the name server for the root servers. So dig ns, that's the query type, dot. We get 13 choices, so I picked one. I think I picked A. So now I'm querying the name servers for org dot. The dot is actually optional. You don't have to add it in dig. And I'm asking the at a.rootservers.net means direct the query at this server. So you can see up here, dig gives us the question section. It says we're looking for org, NS record for org. The authority section, a.root-servers.net has some authority records, and it says that these NS servers are responsible for serving them. And the additional section has the A records for them. Does anyone know why it gives the A records and the NS records when we only asked for the NS records? Corbin.
Only one vote then.
Yeah.
Awesome. I feel like Ken Jennings. It's because otherwise you get some really nasty recursion on the lookups of the NS records. They themselves are named.
Exactly. So they themselves are an A record, like Corbin said. If you want to find out where they are, you have to ask the NS records responsible for that domain, which happens to be the NS servers on that domain. You have to query the NS servers for their own IP address without knowing their IP address. So you have to know where to direct the query. So the servers above them give you some nice information. They say, hey, you can look here if you don't know. If you do know, that's fine. You already know. So now we want to find the name server records for osuosl.org. So we can ask the osuosl.org name servers for an A record. So I picked an IP address from the last query. You can see at the bottom here, a0.org.affiliates-nst.info, 199.19.56.1. I think that's the IP I chose. Yes. And I queried the NS record for osuosl.org. It gives me an answer. NS1, NS2, NS3.off.osuosl.org are responsible for those DNS records. And then it says, hey, if you don't know the IP addresses, they're right here. Almost done. Yes.
You picked an IP address at first.
Yes. So I picked it.
Those IPs are-
Yes, those IP addresses are different. I picked the IP address right here, 199.19.56.1, because this is a DNS server that serves up information for the org domain.
Okay.
So anything, when you register an org domain, part of the registration will tell these groups of servers which servers are responsible for the name records underneath org. So I said, here, I said, who's responsible for osuosl.org? And I asked one of the servers that knows about .org. You just have to keep going and going. So we have some IP addresses for the name servers for osuosl.org. I already knew it because I run them, but we're pretending we don't know them. So finally, we can query for an A record, which is what we wanted in the first place. We query osuosl.org. We ask nameserver1.off.osuosl.org, or I just create its IP address directly. Question section, which is just what I said. Answer section. We have an answer. It's this IP address. It also gives the authority section saying that it's actually responsible for serving those records, and the additional section, giving me the name server records in case I need them. That's a lot of work. Who wants to do that every time you want to query an A record, which is the simplest record type you can query? Anyone? Anyone? No. Corbin.
Excuse me, but I believe that the A record is not actually the simplest record. I believe that the no record is the simplest record.
Not true. The no record was actually added in an RFC after the original set. It was the 7th record type created.
Oh, nice.
Yeah.
Text record somewhere?
Yes, I believe text. Well, that was actually added later too. A record's the first one listed in the original RFC.
Next year, tell me the SSH key type was added later too.
Yes, it was. That was only added like 10 years ago.
SSH hasn't existed that long.
Yeah, not as long as DNS. The original RFC was published in, I believe, 1981 or 1983 for reference. So doing that every single time it's really nice because we know that the answer is correct. We didn't just find some arbitrary server on the internet somewhere that says it knows where osuosl.org is, and it might have directed us to some horrible malware. But it was a lot of work. We don't want to do that. So there's this thing called a DNS cache, which is a DNS server. It will do all of these queries for us, which is really nice. Some common ones: bind, unbound, DNS cache, which is a part of TinyDNS or DJB DNS or NDJB DNS, has a lot of names. There's also DNS mask and a few others. They'll go out and do all the work for us, so we can just query them directly, and they'll make all of the queries we need to.
NSD.
NSD as well, yes. Those are just the ones that I use regularly. CNAME records. When the first time I gave this talk, I actually did not want to talk about CNAME records. They're a pain. They're really nice, but they're a pain. What they are is they stand for canonical name, The canonical name is the thing that the CNAME record points to. The query or the data is what it is pointing to. So in this case, I have an example. I did dig A. I'll explain why I did A instead of CNAME. www.oscosl.org. www.oscosl.org has a CNAME record, which you can see here. Here's the answer. www points to, it's a CNAME, points to web1.oscosl.org. So the canonical name is the thing it points to. The query or the data is what it points, is what does the pointing. The reason I queried for an A record is because you almost always want to resolve to an IP address. I don't really care that www points to web1. I just want to know what the IP address ends up being, which in this case is that. So the reason I don't like CNAME records, there's a specification in the original RFC. They're one of the first records published that says you cannot chain them. You cannot point a CNAME at another CNAME. How many people think that's actually, does that actually happen? Just people, no one follows it. No. It's a specification, it's a standard, no one follows the standard. And there's no rules about how not to follow standards, which is fun. So for quite a while, and there's still, I think there's 2 implementations I know of that still do this. There was no standard on who is responsible for resolving chained CNAME records. And what I mean by that is if you have a chain that's too deep, most of the original DNS servers would look up the first CNAME and just give you the answer, which also happened to be another CNAME record. The client would look at the answer and say, hey, there's no IP address. This must not exist. This is before annex domains existed, so they didn't know there was a no record type. They said there's no IP address, so clearly my query failed. But it didn't. There's another CNAME. You just have to do a little bit more work. There was no specification saying that the server is responsible for doing the extra work, so it failed. Eventually, everyone agreed to always keep querying CNAMEs until you get an A record. So chained records are okay, kind of. Technically, they're not, but they work.
With example, like here, when you're digging for an A record, if you have multiple CNAMEs, will it just keep showing CNAMEs and then eventually an A record at the bottom?
Yes. So if www pointed to web1 and web1 also happened to be a CNAME, this would just say web1 in CNAME, and then it would give the canonical name that web1 pointed to. And then there would be a 3rd line, or maybe a 4th line or 5th line, keep going until I get an A record. If you do query for a CNAME record directly instead of the title just for web1.oscosl.org. You generally only do that when you actually care about the canonical name and not about the IP address, which is pretty rare. Yes, Emily.
So on that previous slide,
Yes.
are you saying it's possible www
oscosl.org is an A record. I could have domain subdomain .oscosl.org also be an A record. Can't do that if oscosl.org was the name. Number 4 is the rule no one follows. Don't chain them. last but not least, and not really last, there's a lot more, is the pointer records. Last one I'm going to talk about. It is like a CNAME, but it is never resolved into an IP address. If you query for an A record, it just won't exist. They'll say, there's no A record. I don't know why you're asking me for one, but it's not there. Pointer records are generally used for what's called reverse DNS lookup or resolution. So what you do is you take your IPv4 address, you reverse the octets. So back here, we had web 1. A record is 140.211.15.183. We take those in the opposite order. Now it's 183, which was the last one, 15, which was the third, 211 the second, 140 the first, and add .in-adder.arpa. ARPA is a top-level domain, still exists for historical reasons. Huh?
Oh, from the ARPANET.
Yeah, it comes from ARPANET. It's actually a backronym. Now it stands for address reverse something something. I can't remember. And we're querying for a pointer record. We don't want an A record. And it says, hey, you have your pointer, and it points to web1.osusl.org. So if you find an IP address, you can run a query like this to find out the host name if someone added the reverse record. Not everyone adds reverse records for a lot of reasons.
And you can make them anything you want.
And you can make them anything you want. I could have put google.com, and no one can do anything about it. It's interesting because the authority chain for .in-adder.arpa records is complicated. It gets delegated out by blocks. Aaron is responsible for delegating IP address blocks to people. They also are responsible for delegating subdomains of in-adder.arpa. So for example, someone owns 140.inadder.arpa and 211.140.inadder.arpa, and they let us own 15.211.140.inadder.arpa. And we have 183 in this case as a specific record. So a lot of people don't have reverse DNS records because you have to go out and figure out who owns your subnet and ask them to give you the SOA and point to you officially. Last one of the things I wanted to talk about was resolve.conf. Who knows what resolve.conf is? Who knows where it lives? It's a file. Where's it live?
That's it.
Yep, Etsy. It's part of your libc implementation, depending on what system you're in. Even Windows uses it. It was around BSDs. Lots of people copied it from BSDs. Other people wrote their own. It tells you which DNS name servers to use when you're using all of your nice libc DNS lookup functions. Dig is not one of those. Dig uses other things. It can hook into libc, but it also doesn't necessarily. So on any system, you can go to etsy/resolve.conf and point to name servers. Standard, you can usually only point to 3. If you want to be crazy and recompile your libc, you can point up to like 8. But that is something that's set in a header file. Most distributions nowadays, especially Linux distributions, provide a package. It's typically called resolve.conf without the dot, which manages your resolve.conf. Because if you're using DHCP, it'll toss a DNS server at you. Yes.
What's DHCP?
What is it? That's a good question. Who wants to answer it? In the back. Yeah. What is it used for? Yeah. So if you don't have a static IP address, you will make a DHCP discover, a DHCP request. Some server will happen to be listening maybe and give you an IP address. It will also give you a DNS server. The resolve.conf package will change the file for you. If you want to run your own local DNS cache, you have to remove the resolve.conf package because it will overwrite your name servers. Or you can be really lazy and just chadder plus I, which makes it immutable, but that's a bad way to do it. That is the end of my structured slides. Who has questions about DNS? You can ask me anything. I'll tell you if I don't know.
DNSSEC?
DNSSEC.
Yeah.
DNSSEC is messy and complicated.
What's it supposed to do? What's it actually doing? Yeah.
That's a great question. What it actually does, I'm going to start with what it actually does. That's controversial. Some people say it actually does stuff. Some people say it does nothing at all. What it's supposed to do is, if we go back to the root servers, Yep. How many people know which protocol, TCP or UDP, DNS typically runs on?
You mean which port or?
Protocol. Do you know a TCP versus UDP?
Yeah, it's going to use UDP for name resolution. We'll use TCP for zone transfer.
Yes, you got it. So zone transfers is just another record type, actually. When you make a zone transfer record request, you do it over TCP. When you do everything else, you do it over UDP. The reason for that is, who doesn't know TCP versus UDP? Okay. The reason for that is you don't want to lose DNS records. UDP, you can lose packets. That's scary. So you use TCP for that, UDP for everything else. How easy is it to spoof an IP address on UDP? In most cases. Mark.
I don't know the answer to that.
Well, Corbin knows. He was raising it.
It's very easy.
Yeah. If you have a network administrator who's really, really smart, it may not be as easy. It's still probably pretty easy. So let's say Alice.
Easy, or are you just good at it?
It's easy.
You fill out a field.
It's really, really easy.
And you don't have to be honest.
Yeah. You basically say, hey, I'm this IP address.
Oh.
And it may or may not make it there, but it probably will.
I see.
If people are smart, then it won't make it there. That doesn't happen very often. So Alice wants to make a DNS request. She asked one of these root servers for com because she wants to know some.com, maybe google.com. Someone, we'll call him Mallory because that's what we always use, is listening on Alice's network, sees this DNS request go through for com. He answers it pointing at his own IP address. He now has full control over whatever Alice tries to visit with her, say she's trying to use her web browser to visit a page. Mallory can now point her to any IP address he wants. That's a problem. DNSSEC tries to solve that problem. Kind of. The goal behind DNSSEC is to provide, it attempts to, like I said before, authority is not coupled with an ideal sense of authority. DNSSEC attempts to use encryption to couple those two back together. So when someone says they're authoritative, you know they are because you have private key and public key pairs. I don't really want to go fully into why DNSSEC doesn't always work or why it's a pain. Part of the reason why is not everyone implements it. Some people do, some people don't. There's also other reasons. It's controversial. It works. Mostly. Sometimes it doesn't. It's probably better than nothing. I wouldn't say don't use it.
So where is it implemented on the client?
Yeah, so it's implemented both in the client and the server. Up until around, I believe it's 2008, none of the root servers had it, so it was effectively useless because you couldn't trust that the root servers were who they said they were. They implemented DNSSEC, and there is a magical public key that everyone has, kind of like how everyone has the root server name records. They exist, they don't really change. Some clients allow you to change them. If they ever do change, you can tell them it changed, but they don't change. You have this public key, they sign the record with their private key that they return to you, and then as part of it, they can also tell you and whoever you're going to go ask in the name server record for. So say you're querying for com name servers. It will tell you that com name servers will use, they'll sign their requests or their answers to your requests with this other public key you can use to check the signage. You keep checking public keys all the way down. One of the reasons why DNSSEC doesn't always work is everyone has to have the private public key pair and implement it. Otherwise, it doesn't really matter because if Google does not implement it, but com does, once you query for google.com, Mallory can just intercept that instead of intercepting your root domain or your root server query. But yeah, DNSSEC it was an attempt that mostly works. Any other questions?
Cool Ruby file.
Define cool.
Well, you got 7 guys that have to get together every 6 months to re-sign the key so the internet keeps working. Like, seriously, this.
I would like my internet to keep working without 7 guys who have to Has anyone seen Lost? Yeah, they have to enter the numbers every, what was it, like 100 and something minutes?
Well, only 5 of them have to show up, but.
Oh, only 5.
Right.
Okay.
But
Yeah.
like, one of them is he goes missing, and then somebody has his key, and now it's a racing. Seriously, this could be a blockbuster, man. Great.
Rubber hose attack. Yes,
I have a question.
absolutely.
In result config, I've seen something like search 192.168.1.1.
Yeah,
And could you explain that, please?
absolutely.
I know
Um,
that's a local IP.
Yeah, yeah, it
It's
is.
not on the web.
It's a little weird to have an IP address in your search. Your resolve comp package will do that for you in some cases when it has no other options. What search does is anytime you make a query, you're using your standard libc implementation, and you don't query for a fully qualified domain name. Who doesn't know what a fully qualified name is? You don't, okay. Fully qualified domain name is the entire thing. So google.com is fully qualified. www.google.com is fully qualified. www.google is not fully qualified. It's just the entire thing.
Technically, to be fully qualified, doesn't it need the dot at the end?
Yes, technically it does. The dot is the root of the tree, but it's implied. So not everyone
My
needs it.
websites don't work if I add the dot.
Your web browser does not understand that the dot is the root.
No, I add the dot, and then Microsoft.com dot doesn't work. It says 400 bad resource. Why is this? Fix it.
I don't work for Microsoft. But to get back to your question, if you make a query for a non-fully qualified domain, it will take a look at whatever you're querying for, and it will add it to your search domain for every single entry. You can have multiple entries. So for example, if your search domain, instead of being 192.168.0.1, is google.com, and you just type dig www, it will automatically try and do www.google.com. So the nice part about the search domain is it allows you to use unqualified domain names, as long as the unqualified name plus the search domain is a fully qualified name.
Where I've seen this in context is when I'm trying to make a connection to the internet using my Linux box.
Uh-huh.
And I get a connection to the local router,
Yes.
but I can't get out.
Okay.
And I tried to change it to put name server 8.8.8.8,
Yep.
because I know that's Google.
Yep.
And it still doesn't work.
Okay.
That's what's confusing to me.
Okay. So where I would start debugging that, do you know how to use ping? So ping, could you ping 8.8.8.8?
No, what I'm assuming is whoever set up the router
Yes.
didn't do it right.
Yeah.
That they're not really connected. They only give local things.
Yes. Yes, that's true. So in that case, DNS won't help you because your DNS query won't make it out and it'll never get answered. So one thing you can do is you can use, you can do netstat-rn. That tells you the routes. So here we have destination 0.0.0.0. That means send all traffic through this particular gateway, which happens to be the gateway on the wireless connection that I'm on. There's some other information which doesn't matter too terribly much. If we use IPA, WLP3S0, that's my wireless card. You can see that the INET address 172.31.100.25/24. If you're familiar with CIDR, you'll know that that means your gateway has to be 172.31.100.1, which is what it was up here at the very top. So things you have to make sure that you have your routing table is correct, so that you can get out. You have to make sure that your device is configured correctly, which is through that. So the first thing I would do is I would try and ping 172.1.31.100.1, which in this case is coming back because there's a device listening there and it's responding. It knows to ping me back. So likely your routing table isn't quite correct. Your CIDR notation is incorrect on your device. You're not using the right broadcast, your net mask or gateway. Or so I'm assuming you're using DHCP with your router.
I didn't set up the router.
Okay.
Say I go to a tavern that says, yes, we have internet.
Yeah.
And I don't get out.
Okay. So there's a couple of other things you can try. If you can ping the gateway, it is worth opening up a web browser and trying to visit a page. They might be redirecting all of your traffic except for your ICMP traffic. And until you accept their terms, it will just redirect all of your traffic and completely destroy it. Yeah, no problem. Back there.
Yeah, SSL for
Yes. How much of the internet uses DNS crypt?
at least one person.
Do you need at least two for it to actually have useful communication between them?
All right, so you have one there.
I mean, at least one server.
Yeah, exactly. You got one server.
Cool. So I don't know what domain uses it, but OpenDNS uses it. Okay, if I ever use OpenDNS servers, then cool. That'd be awesome. I don't, so it doesn't help. But yes, DNS crypt was an attempt to fix DNSSEC, and instead answers in the client and the server.
DNS filtering. when you're on
Yes.
Wi-Fi.
It is a great way of avoiding it. Running your own DNS server is also a great way of avoiding it. But then you're always subject to man in the middle of attacks. It's how much you want to try and avoid it and the risk profile.
What, give me an HTTP error when I try to include the dot at the end?
SNI.
Oh,
Your curl does not handle SNI.
well,
Green light
neither
curl.
does my browser then. 'Cause
Really?
It just says bad request.
Let me see if my browser does. Maybe someone broke it.
It's got to be HTTPS though.
F11, yeah. Or the
Oh yeah.
escape.
We're not going on my head.
Sorry.
And
There we
then
go.
that for new tab. Yeah, wait. There we go.
Oh, you don't have the bottom buttons. That's why.
Oh, and if you close out of history.
Yep.
Yep. There you
Okay.
go.
Thank you. I'm using Emily's laptop because she has Google Hangouts working. HTTPS ocl.org. Update your browser.
No, put the dot at the end.
Oh, you did the dot at the end?
Oh, yeah.
Yeah. We probably don't have
I
SNI.
haven't updated my browser in ages, so.
How do you trust it?
Wait, you're not going to look at the technical details?
No, I know my certs.
You're not gonna look at which cert it is?
Yeah, I'll look at which cert it is. Get certificate. Wrong site. Let's view it. Hey, that's my cert. Yep. Sadly, it's still through GoDaddy. Confirm exception. Yeah. So we run HA proxy with some stuff, and we probably aren't catching the dot at the end because no one actually does that.
I know. It's a great way to break things.
It is. It is. I bet Google handles it correctly. Yeah, they do. They're smart.
Well, Firefox auto-corrected you, so you have to now go back with the full URL
Oh.
and add it in.
Oh, I didn't copy it though. Yep.
I have it really well trained to just like I type geo, pause a split
Yeah.
second and then enter.
So yeah.
Internet's broken.
Same
Yeah.
problem.
So does anyone know what SNI is? Doesn't know what SNI is? Yeah.
Never heard of it.
Effectively, so do you know how SSL works from a high level perspective? basically you encrypt all your traffic,
Yeah,
right?
yeah, you've got a certificate exchange that
yeah.
goes on public.
Yeah, exactly. So when you send a web request to a server, the entire request is encrypted. Web servers have this concept of things called virtual hosts, where it looks at the web header and looks at the domain that you're trying to access and can serve you different web pages based on that domain. When you're using SSL, that header's encrypted. So you have to decrypt it with the right certificate ahead of time, which means you can only use one certificate per IP address, unless you really want to try and decrypt it with every single certificate you have, which can get painful because you then have the overhead of running it every single time for however many certs you have. So SNI is a way around that. Effectively, it passes the HTTP header that is the host in plain text so that the server knows which cert to use to decrypt the traffic instead of having to guess. But it has its own set of problems. It's a little bit more complicated to set up. Your browser has to support it. Lots of command line based tools don't support it at all. libcurl doesn't. Not many people use curl for their browser. Come on, curl. Does anyone else have any DNS related questions? We've gotten quite off topic at this point.
Can you netcat a DNS query?
Sure.
What does it look like? Can you show us?
Yeah, sure. So,
I hope we have netcat. About when you use the same window.
yeah,
Metacapital Q.
Metacapital Q. Thank you. So, netc-L 25, LU 53. I don't know why I was doing 25.
Oh, I may not have it installed.
You don't. There's lots of netcatting implementations.
Do you know the SOCAT flags?
No, I don't. Do
No one
you?
does.
Was Telnet before or after SSL?
Telnet is a very old protocol.
How old is it?
I don't know. Does anyone know how old Telnet is? It's older than me.
At least in the 80s.
Sure. I would be surprised if it was. I wouldn't be surprised if it was from the 70s or 60s.
It's new enough that it uses the high 8-bit in
Yeah.
order to signal, but it's old enough to understand that its terminals are also.
Who understood what Corbin just said? I didn't.
Could you translate? Could someone translate?
Can you translate, Corbin?
Once upon a time, we thought we only needed 7 bits for letters and numbers and punctuation. Then we decided that we actually needed 8 bits.
I'm gonna stop for a second. ASCII is what he's talking about.
Yeah.
Keep going.
And there was a period in between there where computers supported 8 bits for characters, but we only used 7 bits. So the 8 bit was always used for magic signal and stuff.
So we've got 6 minutes left. Any other questions about DNS? Corbin,
I'm a CNA for Emily, whoever handed them.
No, I didn't.
you're a pointer.
You're a man with a cat.
Not close enough to grab her by the arm and
You're
raise.
incorrectly directing a question.
In the back, yes. Yeah.
Since it's done, why would you change it when you have a game for that?
That's a great question.
Oh, they just do it?
They just do it. So, do you know what the point of a CNAME is in general?
I seem to understand that it's rewrite, right?
Yeah. So, if you know that you always want to point to a particular domain and you don't care what the IP address is, then a CNAME is great because it always points to that domain. And if that domain changes the IP address a few hundred times a week, it always returns correctly. Your CNAME is always good. Reason you would point to CNAMEs to multiple CNAMEs is because you really like CNAMEs and you have a CNAME already and you want to make another CNAME and you forget that the first one was the CNAME, so now you have 2 CNAMEs deep. I've seen 6 deep before. So one of the reasons I dislike CNAMEs, I used to work for a company that had a monitoring product, and the monitoring product used a library called UDNS, microDNS. It was useful because it was portable everywhere. Everything could run it, although we only ever ran on Linux. And someone left a nice little comment in the UDNS source code saying we don't resolve CNAMEs recursively. Someone else can take care of that, right? So if a customer entered their website to be monitored, and it was multiple CNAMEs in chain, our UDNS framework would look up the first one, return the CNAME record, see that there's no IP address in the second CNAME in the chain, and say there's no IP address. This record doesn't exist. Caused a problem. Unfortunately, we used microdns because it was used by another tool that was open source that we were using, and we couldn't just switch it out easily. So we had to tell customers to not do change CNAMEs. People don't like it when you tell them not to do things that much. So CNAMEs were a big problem for me when I worked there. Any other questions?
Oh, we're talking about DNS cache poisoning.
Yeah, DNS cache poisoning. So,
Now that's going to be on the local machine, right? Where the poisoning.
it can be anywhere there's caching.
Okay.
So, DNS has expiration times on the records. I pointed those out, but I didn't really talk about it. Does everyone understand what an expiration time in terms of caching is?
Yeah, the TTL.
Yeah, the TTL. Basically, it says if you got the query 600 seconds ago and your expiration time is 605 seconds, keep serving it. Don't worry about it. If you got it 606 seconds ago and the TTL is 605 seconds, you need to requery it. One of the problems is that that is entirely dependent on the client to redo the query and to purge its cache. Not everyone does that, which can cause problems, but that's not cache poisoning. Cache poisoning attacks are when you happen to know, you see that someone is running a DNS cache on a network that you happen to be able to observe traffic for, and you attempt to man in the middle. And you start, anytime they send out a record, they send out a query for a record to some other DNS server, you respond with a packet telling them it's pointing at your server. If you do that often enough and fast enough, all of their cache will start pointing at your DNS records, or at your server, rather. And you now can do whatever you want with it. So rather than man in the middling one person, you can man in the middle a cache server, which is serving for 100 people.
Right.
And you can just keep going up the chain. Much faster to get at people rather than doing it one at a time. Any other questions? Well, thank you guys for, yeah.
You mentioned that DNS sector, the root name servers, they had a public-private key pair that never, ever changed?
The goal is they shouldn't ever change. They do expire, so they'll change eventually.
Okay, I was about to ask what happens if they have a change.
Yes. So what happens if they have a change? DNSSEC breaks until everyone uses the new key pair. And then it unbreaks for a while until it breaks again. That's another problem with DNSSEC. The root name server records basically have never changed. I can't say for sure they've never changed. I haven't looked it up before. They basically never change. Keys should expire. That's a good thing. But that breaks things.
Right, and also if the key ever gets out there, they're going to have to change.
Sure. Yeah. Do you trust the Department of Defense? They have the private key. Do you trust a random company in Sweden? They have the private key. Do you trust a organization in Japan? They also have the private key. Sure. Sure. It's kind of the same problem you get with certificate authority structures, if you're familiar with that.
Yeah.
You trust it as much as you trust everyone.
With the CDH, though, it's the browser effective to define the cluster. In the DNS case, is it the DNS package on the person's system, or what defines the store?
So the store is defined by the client that is making the queries. So however you're making the queries, it has to have support for it. Typically that ends up in libc somewhere or in your resolver that libc calls out to. Most of them nowadays support it. Not all of them did. Not all of them do. I'm sure there's some out there that don't still. Thank you very much.
So the slides may have stopped sharing, but I'm pretty sure it kept sharing audio. So if you hit stop broadcast or
And
yeah,
broadcast.